we did this last time. I think we quick scanned through a few of the sensor and sensor physics last week. We're not going to do redo, but we're going to with that physics understanding, we're going to practice it. We're going to implement it. The first thing that we will do is the ultrasonic distance sensor. This sensors, if you want to practice, here is a good a deal that you can purchase. First of all, has nothing to do with me. This sales, and you don't need to buy. But if you are interested in practicing with a few of the sensors at cheap price, then this is one of the best. If you find any other good deal, then please let me know. I am also interested in purchasing.
But it also came with a CD that had projects for each.
Oh,
each
great!
It's got projects with the code and everything for each one of those sensors.
Wow! So you do have that?
Yep.
Oh, you're lucky. When I purchased that, nothing came up together with this. And another difficulty is that I recently experienced with the funder. Funder is college. Remember that last semester I asked them to purchase, so it took almost forever. So that in this semester I purchased it by myself and then placed the reimbursement. I got a lot of trouble from school, and they kept one guy sent to me email with different questions and all kinds of questions. Finally, I hopefully resolved it, so I may get a check sooner. But it took me about 40 days since I spent my money first. So somehow obstacles. I'm not sure what I can do from next semester.
You have to start the version from now.
I need to request semester ahead. But thing is this, we are doing the technology, high tech. If I wait and see at the last minute, then I will get a better deal. Like Eric this time. He got these stuffs, the same stuffs, but plus the CD, ROM about the practice, which is good, right? Okay, so I edited a little more onto the slides that I posted for the last class, and also this is the revision. They are very similar, but the revision has a lot more slides with detailed the explanation that I think would be useful for you. This is a general idea when you do sensor labs. The steps that I prepared here, not necessarily common for all kinds of sensors. This is pretty much from my experience helpful if you deal with chip sensors. Chip means like $1 or at the most expensive $5 or $10 expensive sensors to consider. Then the steps that I described here may work. But some other sensors, if related with health issues, then goes up to $100, right? One of the sensors here in this slide, if I don't remember which one, but some of them here there is, I think, heartbeat sensor. So if you touch or place that on somewhere sensible skin, then it can tell you the heartbeat. That is included in this bundle, which means maybe the price of that is maybe 50 cents, right? Not more than $1. But anyway, that is that. So let's take a look this together. The procurement of all parts first. Of course, if you have the parts available, parts means what? Parts, first of all, sensor. What else? Arduino. Breadboard. Resistors. Switch. LED. Something missing so far. Something that is.
The power, the cable.
The code.
Yeah, code like jumper cable and then USB connector. So that USB connector is needed for what reason?
Just to upload the code.
Yeah, the coding, right? Coding purpose, then you have to do that. So as far as while you are doing code, your Arduino Uno can receive power from your laptop, so that will be okay. Once it is successfully coded, compiled, and uploaded and functioning, so that if you want to deploy that to some place, then it needs its own power supply. If you want to deploy it in the nature, then probably you need solar power, solar cell, solar panels. Solar panels, I think that may be the most expensive in that implementation. Solar power, about $100, right? Usually solar panel generates 12 volt voltages. That is a standard. 12 voltage, then it supplies to almost all the electronic devices. If you have a surveillance camera, then it can also. Arduino Uno is a 5 volts and 3.3. It can take up to 9 volts. 12 voltage may be too high. Then you need to have some regulators. So drop down the voltage a little bit. Little bit. It's not. I mean that from 12 volt to 5. I don't think it is really expensive. You can save. You don't need to buy. You don't need to supply the batteries continually, right? So you can get it from the sun. Sun. Yeah, we have sunlights. Okay, so once we have all the parts ready, then get familiar with the detailed specification of the sensors. There are all kinds of resources available. Sometimes it can come with your purchase, but not all the time. Usually, sensors that I received so far, there's no printed specifications. So you need to find out from the internet. Circuitry is the first thing that you have to conform. Okay, if you miss input and output voltages, I mean input voltage and ground, miss connection or data to voltages. Sometimes if blowout. And then if you are familiar with the specification, then using the jumper cables, you can connect the circuits. In that case, you also need to report to a sample circuits, which may be available somewhere. If you have, sometimes if you need the resistors, usually if you buy the sensors, for example, LED separately, simply LED only, then you usually need the resistors. Is a register or a resistor? Register. If you use some of this, for example, IR receiver that we are going to work on, and program for LED, or more specifically programming for your remote controller, then if you buy, for example, individual LED and individual LED receiver, then you need to buy specific the proper the size of resistors. But if you use this, the one from this bundle, then it already inside it's all safety safety is confirmed, so you do not have to worry about it. Step 3: coding on Arduino IDE on the host and compile it locally, and then again, when you do code, better to refer to a sample sketch. Sample sketch. Sorry, this is not scratch. Sample sketch. Sample sketch. Sample sketch. Which may be also available in the internet. In some cases, if you need to download the Arduino libraries, for example, IR sensors, anything related with infrared sensors, usually it's not built-in, so you may need to download it extra, so that you can avoid all detailed implementation, but simply use it. And then connect it to the Arduino. Your Arduino needs to be configured, the type of Arduino and then port. Port sometimes if we have Windows systems, I think same as Mac, port number is sensitive, so some Windows systems are lazy, doesn't display the proper ports that's available currently. Then you need to make sure that you need to unplug and plug in until your Windows systems recognize the ports that you use currently. Okay, that is the most important. Some Windows systems, from my experience with students, Windows systems, does not have any port recognition capabilities on their Windows. In such case, you have to download extra port diagonalizer or port identifier. Some of the applications is freeware, so you have to activate the ports identifier. Okay, that is the worst case. If anyone has that problem, then that is the special case on your laptop. Don't worry about it. There's a manufacturer issue, so you can resolve that by downloading and installing the port recognizer. Okay, so make sure that your Arduino is communicating with your laptop where there is a sketch, your C programming. Okay. And then upload the code and then run. Many cases, we're not doing any further, but simply see the data communication. Then you can open up the serial monitor so that you can see the data coming in and out, right? That's what we are going to do. This is a sample code. You know, Arduino microcontroller. First of all, there are a lot of Arduino controllers, right? All different kinds of size, capabilities, dimensions, and purposes. So Uno is the cheapest, and Uno means one, right? So this is number one. Number one, not in quality, but number one. So you can start with this. Arduino program, which is C, provides you, IDE, Arduino IDE provides you by default two modules, setup and loop, setup and loop. And then you can fill in inside. In setup, you need to configure pin modes and registers. And in loop module, you can run a main body of the program. So it runs forever. Although you do not use, for example, while loop, for loop, or any other, by default, it iterates forever. It doesn't mean that you cannot do any additional loop inside. So you can still do some loop inside. So inner loops possible. But that is the loop. Once your Arduino sensors are ready to set up, once it is set up properly, then there is one iteration loop. Okay. Like many other programming, if you, someone may ask us, would there be only two modules? Can we have more modules? Like if we have multiple functions? Yes, we can, right? We can have a void and some other return type and then function name and then parameters and then block of that function. We have more than and as many functions as you want. You can put more and more, and can be invoked from your loop. So this guy invoke this module, and this guy invoke another, and another statements in the loop invoke one of these, which is invoke others here. So this Arduino programs can be very powerful, having multiple functions implemented, in addition to setup and loop functions. But there is a size limit. Size limit is the Arduino Uno has 256K RAM size, so it should be that is a RAM that you can use. Okay, not the compiler or operating systems itself, but only for user purpose, user usages, you can use 256K, which is quite a lot also, right? How many lines? 256. I don't know. Okay, you can calculate it. The first exercise is this. What is this? Which sensor?
Ultrasonic distance sensor.
Distance sensor. Okay. So I know you have Arduino Uno, and I'm going to give to you this ultrasonic distance sensor. And keyboard. Let me first introduce. Don't. This sketch is from somewhere in the internet, so you do not have to. We do not going to put the LED lights. So ignore red LED or green LED here. But we're going to monitor the data transmission from your laptop as you connect your Arduino Uno to your laptop. Okay. Oh, by the way, previous recording, the recording that the video clips that I recorded for the last session, have you watched that? There's no videos, right? Only my my audio. But anyway, I don't know why it happens. So I cannot report. But anyway, so I hopefully this time it'll work perfectly. Good. Let me explain this this one. Remember that last time we looked at this, right? So looked at the speed of sound and compare that so that we can see the distance. What we will do here is, this is Arduino Uno. You need to, this guy has power supplies, right? Power definitely should be supplied from your Arduino Uno, but in this diagram, simply we have a ground and then voltages. Usually you can put 5 voltages. And it has 4 pins. So power supply and ground, two pins for related with the power, and the other two pins, one for trigger and one for echo. Why we have two pins? Why we need the two pins? Is in this regard, right? One emitter here is ILM. I mean ultrasonic, right? Ultrasonic. The sound is sent out from one device, sent out, and when it reach an object, then there may be a reflective signals. That signals can be captured by, received by the other sensor. So we have a trigger and echo, two compartment. Each one has the pin here, pin. So you can using the jumper cable, you can plug in this way. Do you have a jumper cable? You do not have one. Do you? Did I give it to you or you? Oh,
Oh, okay.
so okay. And then so you can
choose any pin, or it has to be 13 and 12 for the trigger and echo. We can.
Don't go further. Just
this is the power, and this is the ground. The trigger.
Not yet.
No. Remove.
Yeah.
Okay.
Yeah. It's powered already, right?
Yeah, but it's not connected to.
Oh, okay.
So that's it.
Right.
Esther, do you need another breadboard?
Oh yeah, I have. You need a breadboard?
No.
Oh, we don't need for this.
Oh, we're not going to need breadboard? Oh.
Yeah, we don't need. Right. Directly connected to two pins for the digital slots, and the other two pins for the power and ground. So it's simple to check. So you can plug the jumper cable to. You need 4 jumper cables, right? One female and one male. Female can be plugged in this sensor, right? And male will be plugged in your Arduino Uno later, okay? So knowing that, so you need to make sure that which pins what. When you plugged in the jumper cables, and the other end of your jumper cable, you have to make sure that which one's power in, and which one's ground, which one's trigger, which one's echo. So you have 4 pins, 4 outlets like this, right? I wish I can show this to our. When I practice this, the recorder from my Mac, it's not automatic. There's no button that I can switch back and forth. For example, turn on the camera, the webcam, and then screen capture. There's no quick way that I can switch it on and off. So that I'm going to do it after the completion of this. Okay, so coding is this. Let me explain this coding. So by looking at this coding, then you can see which one that you want to plug in. Not necessarily 13 and 12, but if you use this code, then trigger pins, this is your name. So # define. You need to, that is a reserved word, which means I want to define the pin number 13 of your Arduino Uno as a trigger pin. In that way, from your sensor, the trigger pin should be plugged in the pin number 13. You can change this. Whatever, if you change this to 7, then in real circuits, you have to plug that pin into the number 7 of Arduino Uno. Similarly, echo pin 12. That's what we did right now. And then we have 2 modules, setup and loop. And this is setup. We also need serial communication. Baud rate. This is also sensitive. If you set 9600, fine. But it should be matched with the monitor. Okay.
What's the monitor?
Monitor that we will see from your IDE.
Remember when we open up the show, we open up and we see the beats or whatever. This is the monitor.
And then in this setup, you need to now, as you define the pin number here, now you need to turn on. For example, pin mode trigger pin, that is the output, and then echo pin, that is the input. See, trigger is that from the trigger compartment of your sensor, you need to send out the signals, right? There's output. Trigger send out the ultrasonic signal. And then echo pin should receive that reflected ultrasonic sound signals. So that is the input. So as you set up that way, then we have one loop from here to here. This guy should be after this. Okay.
Inside the loop.
No, after this. We have if statements here. So this is
Okay.
the end of that if statements.
Okay.
In this loop, we define also 2 variables, duration and distance. So digital write, the trigger pin, I can simply turn off. Low means turn off. High means I turn on. So initially, I can do by 2 seconds, 2 microseconds, wait, and then I can turn on the trigger pins. And then delay 10 microsecond. And then I also trigger pins. I think yeah, low and high, low, high, and low. This is voltages. So with like a pulse, we can send out 2 pulse sent out. And then we check the duration. There is a function called the pulse in from the echo pin. So we turn on the echo pins. There's a duration. We check the time intervals. So think about that physics, right? Triggers send out ultrasound with some interval. Interval here 2 microseconds, right? 2 microseconds. And then no. Is it 10? I think 10. Let's take a look. So we take the time distance. So duration is the duration after first send out and second send out. So when it travels round the trip, right? So we have to, the real distance is half of those round the trip. So distance divided by 2. And then because this is a sound, we are talking about now centimeter. So according to some physics, we need to divide it by 29.1. It's not really the same as this is 58, but we already divided by 2 and then 29, so that is 58, right? That is 58 centimeter. Remember here, 58 centimeter. That is exactly here. If we divide by 2 and again divided by 29.1, then that is almost 58, right? So that is the distance. By checking the time distance, time duration, we divide it by 58, almost 58. Then that is the distance. So that we can print serial.print distance. Okay. This, when you, whatever you say, serial.print, it can be displayed on your monitor. If you do not write anything serial.print, then you do not see it. Okay. So you see the distance, and then this is one extra. If a distance is less than 4 centimeter, then you say something, and then you can say there is a long distance. And another, if distance is greater than or equal to 400, then you can say out of range, and else you can say and print that, and then simply finally types centimeter, and then delay 500 microsecond and redo this continually. What happens here is that if you place an object close to your sensor within that short time period, I mean, if you avoid that time windows, then this sensor doesn't catch you, right? If you are so sensitive and so lucky, then you can detour that time windows. So usually, if you tick the trigger, triggers so often, and if this delay is too short, then it triggers all the time, so that there is no time window that you can avoid it from, right? But depending upon that calibration, there may be some black time windows possible. There's another trick, right? But if you keep sending out and receiving it so often, what happens? Then you consume the battery so quickly, so the lifetime of your sensor will be short. As far as you have power supplies, if you want to have, if you do not allow any black time windows, then you need to shorten the delay time here, 500. What's some of the time here? 2 microseconds and some of 10 microseconds. You have to,
Professor,
yeah.
just a question. In this case, when we are using the echo pin in the I mode, here we're using the I for the echo and the low for the trig pin. So it should be in separately. So it should be alternate. So the one, the
Correct.
trigger
Yeah, you can
one has to be
send
low.
out and
So when it's not sending, you
it's
can
not
receive
keep
it.
sending.
Yeah,
Then
okay,
we
so
do not know. There's no way that we can calculate the time.
instead, the echo pin has to be always high, or right? We just have the delay.
Right.
But
We simply receive it. Right.
Okay.
It depends on the trigger.
So you have in this
We
case,
cannot turn it off. If we turn it off, then there is an echo, but we miss it. If we some points turn it off, so that we leave it on continually, and everything is based upon the tick from the trigger. So send out trigger signals is triggered from the trigger pins. So trigger pins controls the time intervals. I think this is the sketch. So what we will do, I'm going to switch our, this is so inconvenient, but this is the way that I need to.
in this case, it's just showing us, I don't know, which, maybe output pin, 22 centimeters, 3 centimeters from, 3 centimeters really? 70, how come this 70? Which one? So the trigger, the echo is this, right? This?
Hold on. So this is the Arduino. Oh no, wait a minute. Is this the one? Oh yeah. I think I need to show this to you. I think some of you already knew this, but let me explain a little bit about Arduino IDE. So what is a microcontroller? Microcontroller is like a small computer that can it has a CPU and a small memory, and allows peripheral devices to be connected, and analog digital converter, serial communication hardware, and all. The usages of microcontroller is now everywhere. You know that these days Internet of Things is one of a buzzword. Internet of Things is really possible simply because the sensors are available. And where there is a sensor, then there is also microcontrollers behind. So microcontrollers with the sensors are available in a car, phone, toothbrush, microwave oven, copier, television, PC keyboard, appliances, all kinds of things. So you can find out additional from by clicking this URL. And one of the microcontroller is Arduino. Arduino is a special purpose and specially designed for sensor network, which is unique from many other microcontroller. For example, what other microcontrollers that you know?
Yeah.
Raspberry Pi.
Raspberry Pi, BeagleBones, and there are so many others, right? But the other BeagleBones or Raspberry Pis are nothing but the computer. That is a general purpose. But Arduino is a special purpose, can designed for sensor networks. So Arduino Uno means three things. There's a hardware device, and Arduino means that is a programming environment, which is IDE. Arduino means it is a community. There's big communities available. And somebody said there is also a philosophy. Okay. If you have Arduino Uno on your hand, then you can see there is a reset button, which means you have one program loaded and runs. At some points, you change your program. Of course, if you have different sensors embedded, plugged in, then you need to make for different sketch, different coding, right? And in that case, you may reset. Or for any reasons, if there is a buffer full somehow, input and output network buffer full, and if there is those signals coming in and going out, then you can also reset. For any reason that you can reset yours, okay? And then generally there are two sets of pins, digital I/O pin and analog pins. Here we have analog pins and digital pins. Digital pins, there's numbers from 0 to 11, 13, actually 13 here, right? 0 and 1 are usually predefined receiving and transmission. You can still use this for other purpose. But if you do not program on your own, then you can simply use it for input and output. I mean, transmission and receiving. And all other pins that you have to read it from, or you can write it into through the pins, so that as we looked at the sample code for ultrasonic, you have to define it and you have to set up properly. And then there is a LEDs. There's a few LEDs available. If you have this LED on, which means it has a power. And another LED, this LED is particularly for pin 13, so that you can see 13. In our experiments, 13 is for trigger, right? Trigger pins. So you can see the trigger. If there is a trigger, ultrasound is triggering, then you can see that LED on and off. This is only for your simple checkpoints. If this is on and off, then you can, without looking at any additional monitoring environment, you can see simply by looking at this LED, you can see, oh, there is something going on through the pin number 13. Okay, there is another LED for transmission and receiving, which is pin number 1 and 2. If you have any external devices connected through pin number 1 and 2, then you can see also LED on and off here, TX and RX. So TX and RX and 13 LED, and there is a power LED. So we have here memory. And then the microcontroller, tiny operating systems already built in. If you have Arduino UNE, which is for Wi-Fi, then it has a lot bigger capacity of the RAM, where there are, I think, multiple different operating systems shells available. One of the shell is Linux, Ubuntu, so you can switch back and forth very quickly. If you have a Linux here, like Ubuntu, Arduino Uno, Arduino UNE, then that is almost like other microcontroller. For example, Raspberry Pi. And analog input pins, we have 6 analog input pins from A0 to A5. And then we have power pins if you want. And the other side we have power jack. The power is supplied not from the USB but other external regulator. Then you can plug that into this pin. Okay, I think this is it. And then next one is, yeah, I explained that. If you use an analog input, then let's say voltage range is from 0 to 5. So you can convert to that. Let's say that is 10 bits for the points of resolution. So 10 bits means 10 to the power 10, which is 1024, right? 1024. If you count it from 0, then from 0 to 10,023. So range of the power range from the analog input is 0 to 5 voltages. But we can you can convert to that analog voltage to digital, because this is 10 bit resolution. Then we can convert to the analog voltages from 0 to 5 to the digital range from 0 to 1023 proportionally. So 5 voltage is nothing but 1023 points, and 0 voltage is 0 points. Let's say then what is a 1 volt? 1 volt is, I think, about 200 something, right? But if we use 3.3 voltages, then that is a little different, right? 3.3 voltage means 1023 times 3.3 over 5, then that is 675 points of resolution. You can convert to that. You don't have to worry about this right now, but further experiments you could do. So 6 analog pins and but if you have a mega board, then it has 16 analog pins, and if you have a nano board, it has 8 analog input pins. This is for others, not this module, not this type Uno. Then we have 6 pins. And other flavors, you can take a look. Some others. Ours is Uno here. This is ours, right? $30. was about 2 years ago, but now about $10. Mega is also half price right now. Nano, this is small ones, and Lily, round, like a discus shape, so that you can place it in your something, your goggle, Google goggle. The processor of the Arduino Uno and many other microcontroller is an Atmel AVR. So we're not going to study this. When I taught the first time, I looked at this a lot, but not anymore. Right? AVR is stemmed from Harvard architecture, 8-bit RISC architecture, but now very popular. So Arduino IDE is available to download. So I want to download this. Okay, that is GUI based, so very, very friendly. Some other students who wants to do more technical, deeper, to be a sensor hacker and modify and do something, then you can download it, AVRDUDE. This is another tools. That is a command line. You need to also learn the command line. Again, about 5 or 6 years ago when I first introduced this to our Mercy, I used also command line. But okay, make it simple. This is simple AVRDUDE for Windows. You can download it from there, and it has some like Linux like something. This is posted, so you don't have to. Yeah, and then yeah, already posted. And then Mac version of AVRDUDE also available. And you can, in that case, you need to use Mac terminals, right? And this slide shows you the Arduino IDE, right? We have here, this is for Windows. If we have Mac, then you will see Mac version. I'm going to bring up Mac version a little later. This is for Windows. So do we have a menu on top, like drill down menus available. So usually the first thing that you need to do is the tools drill down menu. Then you need to configure for the type of Arduino and the port number that is available in this tool menu. Once you set up and deploy it and still wants to see the data transmission, then there is a serial monitor available in this tools menu, so you can use it. There are two icons here most time that you use. Check button, that's for compiler. So when you do coding, complete the coding, and to see, to make sure that that is operational, then you need to click this button, and then it compiles it. This button has nothing to do with the Arduino yet. So you can click this button to compile locally. And then there is another button, right arrow. If you click this, then this means upload. Therefore, Arduino Uno should be available and connected, and all sensors should be properly wired. If there is any other severe miswired components available, then as soon it is loaded and power is on, then you may lose some. And then bottom, that is output, standard outputs. It's not input. So that you can see some messages from the compiler, from the loader of that. If you have any errors, then you need to take a look at this. Sometimes you might have long messages, then you need to scroll up and down this. You can, this compile is, when you click that check button, internally what it does is that it compiles this. This is command line. AVR-G++, this is C program. -C, -G, we have a debugger, and then this is typical C compiling, right? You don't have to worry about this. Simply click the check button for compilation. But internally, it works like this. Okay? And if you do upload, internally, it is uploaded in this way. If you use this AVRDUDE, this is a command line. Again, you don't need to worry about this. Simply click the arrow button. If there's any error, then you can see some of the, oh, this is not the error because it says done uploading, right? Many cases, if you have messages in white, means okay. A few cases, if you have red messages, then you have to watch a little bit. But before you watch, you have to look at this global message. If it says done, then it is done, right? Maybe some warning messages in some others. There's other colors like amber colors, so you can see some other minors. Okay. And this is another command line, other command line if you want to do. Okay. What is this? Yeah, this is a command line. See here, AVRDUDE and some other combinations, and then you can put some hacks, and you don't have to worry about it. Okay. So having that said, see, for those who are working on Mac, then if you download the IDE successfully, then you can bring it to the home. Okay, so this is the home Arduino. Arduino is a self-contained executable file. I think it's one file, right? Or is it installed? I think it is installed. I don't remember. Okay, that's okay. So if you click this, then you can see this Arduino. And initially you have two modules provided, setup and loop. For the Mac user, we do not have any menu up here, only the icons. But instead, very on top of this Windows, there is a file, edit, sketch, and tools. So if you want to open, I think I have some of the files already. So let me try to open it. Documents, and then there is Arduino, right? And then I have, what is that? That is ultrasonic distance, right? So I think I did that last night at home somewhere here. Motion detector. I think this is a distance, right? See if I open this. Then I need to open this. All right. So this is the code that that we just looked at, right? For example, distance is the duration over 2 and also divided by further 29. Altogether, you can simply say divided by 58, right? You could do that too. So right now we are at this phase, which means I can verify it to see if it runs well. It says done compiling. Now I am ready to upload, but I'm going to get ready for my Arduino Uno. Before I do that, I need to plug in Arduino Uno into one of the USB port here. And then I need to see the tools, and then board Arduino Uno. Automatically, it tells me that Arduino Uno that is checked, so I am okay, right? Okay, so I'm going to turn off this recording, and then I will turn on the webcam. Okay, so here I need to stop. I think it is automatically shown, I guess, right? So this is ultrasonic distance. You cannot see here in class, right? Is there any motion that you can see? Yeah, you can see from there. So make sure that, let's try. The ground, which is a white color code in my case, I can put it into the ground pin into my Arduino. And then the other end of this, see here, we said trigger, and then VCC, that is the other end, which is blue pin, so that I can plug that into the 5 volts here. 1, 2, 3, yeah, 5 volts there. So 2 pins used to both ends. And then I have a trigger pin just next to that blue cable, which looks like a purple cable. So I'm going to take purple cable into the pin 13, digital pin number 13. So I'm going to put that in the 13 here. And finally, I think the gray, the color, which is echo pin. So I'm going to take the gray pin, put it into the pin number 12. So 4 pins out from my sensor and 4 pins plugged into the Arduino Uno, like this. And I need to make sure that again pin 13, a trigger pin is a 13 and echo pin 12, so that I can upload it. So when I do upload, program is not responding. What happens? This is one of the good examples of uploading error. So I unplug and plug it again, and make sure that I have yeah, that and that. Yeah, I think I'm okay. And redo. Compile is okay. And then uploading. Done uploading, right? It is done. And then it's not triggering actually. We'll see. So I'm going to turn on the serial monitor. In the tools menu, there is a serial monitor. I'm going to turn that on. And then there is a distance. Somehow, if I move this to up, then that is out of range and a little bit. Somewhere here, very short when I place my hands and little. If I put the other side, and then my hands in, so it is only 66 centimeter. About that, right? When I turn this little to my monitor, 16 centimeter. How much is centimeter? 10 centimeter is 100 centimeter is what?
This is like more than 1 kilometer and 600.
This
So
is not
too
right.
much. It's too much.
I think it's a calibration issue, right?
Yeah.
It's a sensor. It's not really sensing well. I think we can change it. How can we change it?
But if it's really close, it's gonna recognize 3 centimeters.
Oh, that
Yeah, this 3 centimeters is
did
correct.
works, right?
Yeah.
And if
Just
I do, oh, what happens is that it does not recognize the longer. So we can tweak here. If distance is less than 4, then we can say less than 4, or otherwise here.
Yeah.
Oh, is it distance? We have to do this carefully. If this is less than that, else we need to put here else else if oh no, editor is not really familiar with that. Else if that is greater than 20, then we do that. And then else, which is in between, right? Then we can do distance and say that. How about this? In logic,
Those brackets.
what happened here is that I think it should be better. So I can compile it. Done. Then upload. done, and then we can do okay. Oh, still 2 kilo, which means 2 kilometer.
Yep.
Still not correct. Then I think we need to do, what about, I'm not sure if it works. Scale down, 1 magnitude. Long distance, short distance. Too short. 3. I don't know what. There is no centimeter out of range. Short distance and long distance. What happens here? No, this is not long distance. We need to tweak a little bit further. Rather than print ln, I'm going to put here in this way. That looks better. And then short range. Else if that, and then we need to do okay.
Professor, I recognize that one is pretty much showing us 2000 centimeters. It's pretty much 20 centimeters. So it's just going to be the measurement of the centimeter,
Yeah.
meter, and centimeter.
Right. The sensor, the quality of a sensor that we have is not really high quality. So sometimes it doesn't make sense. So that may be okay. Why didn't say the word? If distance is less than that, then short distance. Oh, then I have to say, yeah, that is regular. So we can put here more. Print. We can say okay. Then compile. Load. And monitor. Okay, so this makes more sense. Here you go, that and out of range. If we do this, oh, see, to the wall. That is this okay? Like 100.
41? No.
41.
No. This
Three
is
feet?
pretty much
3.5 feet.
1 meter and a half, something like that. 1.4 is going to be less than 141.
Yeah, I mean that's.
It's just a simple.
It's not. Yeah, it's similar to that. It is not really accurate. So if I do this,
It's like
Let's get
No,
a
here.
computer.
if I do this, out of range, right?
yeah, out of range.
If I do this,
Yes. 7, 6.
yeah, this makes sense. So yeah, it's relatively okay. It's not really accurate. Why? Because this is cheap, right? But it works actually. this is the way that we could do. I'm going to turn this off, and what I'm going to do is I'm going to do stop it. LED. So far, we don't see any critical points that that we see potential cyber threats when we practiced with distance sensors, right? Not much. But for LED, we might have. LED, if you have a LED emitter, then this is emitter, which means you can turn on and off the lights itself. Then there's two different sides of legs. Shorter legs is negative, and longer leg means positive. Positive means you need to supply the power there, and the negative means just put it into ground. If you have a receiver, then grounded this particular the receiver, this LED, then this is the signal, and this is a ground, this is a voltages. There is no standard at all. So each manufacturer has its own specification, its own pin definition. So you have to always make sure that which one is what. Okay. So this is IR detector. If you want to do infrared sensor, then you need to download the infrared libraries. You can download it from there.
I tried, Professor, but it seems to be the page we are looking for this blog does not exist.
Is that right? How can I?
Is that one? I don't know if it's correct, Professor.
Oh yeah.
Doesn't
Ken Sheriff is the one.
Oh.
Hold on, let me see. Copy this, and we can go to not fair. I'm sorry.
Oh, no, Professor. I show you that.
Oh, do I have a magic touch? No. I think it be spelled somewhere. And then there is a the 1.2 GIT hub. Let's see. So installation instructions. Which one did I need to see? There's no download. Is this the one? Let's click this. Oh yeah, this is the one that we need to download. So download the zip files. Is there any? This is the URL https://github z3t0/Arduino-IR remote. So this is a text file, so it doesn't mean that it is related with any platforms. Therefore, we can simply download the zip. For Mac user, then you need to go to Arduino, this, as I mentioned there, you need to download it, and then you need to change it to IR remote. So it should not be masters something. Take out Arduino also and simply IR remote. Where is Arduino in my case? I think Arduino libraries. Yeah, I need to put that there. So copy it. Arduino libraries. There you need to paste it. IR remote. Okay. For Windows user, I specified that here. You need to put it into program files. There is Arduino directory and libraries, and put it there. Once you put it there, then let's bring up this Arduino. I don't need this anymore. I don't need this. Let me reopen the Arduino. What happens here is that go to File, Examples, and go down. Then there is a IR remote. If you see that IR remote in the examples, I think it will be okay. So that you can use all IR stuffs. Okay, infrared. So let's move further. Okay, this is what we are going to do. The one that you can find from the keys, then there is an IR receiver. I'm going to give it to you, IR receiver. I think Eric, you have IR receiver, right? Mm-hmm. Yeah, pull out IR receiver, but I have a few extra for you to practice. I have here IR receiver. Going to practice some others. What we're going to do is infrared signals, as an example, received from your remote con, okay, TV set remote con, any remote cons that you might have. So I brought up my remote con. This works well. I'm going to explain this first to you, and then we can practice. All right. Yours is very similar to this. This is a case, and then if you I wanted to put it back to that the plastic bag. Therefore, I can identify with some others. I have so many sensors in one big envelope for today. I cannot bring. There is a you cannot see it very clearly which pin is what, right? But if you see that on the right side pin, there is a mark S, and then left side there is a mark minus. That is for ground, which means then by default in the middle pin is nothing but the power. Let me see yours.
Mine is different. But I do have,
yours may be improved. Oh, G for ground. All Y.
the S is on that side there, so I'm going to assume that the.
Oh yeah. I think the pin, the order of a pin is the same as ours, but it has a different label. Therefore, each sensor, although manufactured from the same company, different labels like this time. So you have to always make sure that don't follow any sketches, any the wiring, the configuration. Although it is available from the web, yours is not exactly the same as their demo. So yours is yours. So you have to always make sure that yours is properly configured and sketched under the same concept. Okay. So that is the understanding of this IR receiver. The sketch is as follows here. You have to include IR remote.h. In this way, remember that we downloaded this, right? IR remote. Put it in the proper place, the library, as a directory. Then under that directory, you have .h files, header files. So that is okay. The receiver pin 11, which is the signal pins of your IR receiver. So from this 11 pins, we will do some, right? This IR remote the folder directories contains the functions, so that it understands IR receive, decode result. This IR receive function takes this pin and then we declare the result. The type of result is a decode underscore result, the old result word. And in the setup module, we do serial dot begin 9600. By the way, if you we'll get that right later. And then IL receive, that's that function, right? IL receive enable IL pin, then this pin is enabled. In the loop, IL receive decode, and then put it into this result. This is that variable. Ampersand here in C code means that is a dereference. Result is the variable. What I'm going to do is that I'm going to whatever I receive, I'm going to put the result into that variable. If that exists, then we can do in this series within that if block. In this if block, first thing that we do is we print in hexacode, and then we resume, which means I'm going to current to receive will be resumed, so the reset and ready to receive. And then we take about 200 microsecond and re-receive. What happens is here is that we have a remote controller, and then we press one button. Then it reads the signal from this. This signal has, see here, LED, but lights is not on. But signal is still going out. When I press the button, then in this manufacturer, if I press, for example, power button, then I want to send some data on top of that LED signal. So LED is a carrier of that message. Message is whatever we want to send from this remote con. Then receiver, for example, TV sets. TV sets, there is a receiver like we have here. This one is at the TV side, and this one is on your hand. When you press the button, then TV sets detect it and then recognize by looking at the message there. If that message, we do not know yet what message is carried from this remote con. That's what we want to look for. Okay, what is the code? What is the code assigned to this button, for example? One button from another button. There's a manufacturer's decision, right? That's what we want to look at. So, the similar way that we did, let's start here. And pound sign include IL remote.h. Then I'm going to say it what I'm going to do is rather than redo, I'm going to, because I did that already, I'm going to open it. But meanwhile, I want you to do yours. Where I have that. course, no. Documents, Arduino, library, no, not to library. Arduino. What I did was IR detector. IR detector 1, open. Okay. I think this is the same as I'm going to save this. The same as that code, right? I'm going to this is not right. This is not what I want. Oh, I'll receive. This is what I want. I'll receive. Yeah. Right, this is the one, and I'm going to compile it, and I'm going to do what I'm going to do is that I'm going to unplug the previous one, and I'm going to plug it. Oops, okay. So here, this is IR receiver. I have the pin here. S is for signal, so I'm going to put the signal to orange pin, and power ground white and power green. Power green and ground white. I usually put the white for ground, or in this case yellow. Yellow for ground. Okay. Back to our Arduino Uno. As we look at here, the receiver pin, the signal pin should be plugged in to the number 11, digital pin 11. So 8, 9, 10, 11. Okay, 11. And then power line, which is green. Green should be in power 5. And then ground to the ground. All right, this is it. And then let's take a look. That is correct so far. And then we can upload. Okay, upload is done. And then I'm going to open up this, right? And then what I'm going to do is I have a remote con. If I press power button is E0E040BF. or 8 BF, right? Look at the monitor. Do you have yours?
Yeah, but it's a different, different hexacode, but it's okay. It's working.
Oh, great. And then if I press channel up, then that is E0, E0, 4887. Channel down, E0, E0, 8F7. Volume up, E0, 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 1F. And volume down, then E0, E0, D0, 2F. What happens here is E0, E0, this is not, this is a 4-byte long, right? E0 is 4-byte long messages. So 32-bit message. 32-bit message. First 2 bytes are always the same, right? In this case. What about yours?
For me,
First 2 bytes.
I have different.
How many bytes totals?
No, sometimes it has different sides, but it always replicate. So it's like
Oh, there is only.
Yeah. Then here it was one of the button, and then it always go to the
all different sides. Yeah. Okay. That's fine.
You want to
yeah.
test with other
so, if I have any button here, it has some something.
Same size,
right. For example, number button. If I put 1, that is that. 2, 3, 4, 5, 6, 7, 8, 9, and all kinds of button here from my remote con send
Send to me, Professor.
I can send yours.
Oh, you receive mine?
Yes, I'm receiving yours.
Oh, great.
Okay.
Oh,
so
this.
To the professor, you will see the difference.
So I'm going to send it to you. Make sure that this is not the program done. So we need to identify. We need to codify this.
So each one of that has to be.
Power. You need to write down somewhere.
Yeah, it's
power.
already there in the monitor.
Okay. And then let's do a few of them. We don't have to do all of this, right? Channel up, channel change up, channel up,
Okay.
and channel down. What is the number channel down? E0, E0, 08F7, right?
Yes.
And volume up, which means a volume plus, and volume down. And let's take one more. The one that I did in my example was a mute. If I press mute, there is a mute. Okay, I think that's enough. So in my another extension, remember that this is what I did, what we did so far, and another extension here. What I did here is in this slide, knowing the hex signals, the code can identify. This code identifies it. This is extension from the previous. All other the same. Only I put here, for example, message, and then I here message is the result value dot hex comma hex, and then using the switch statements, if message is in hex 0x in hex, if it is 40BF, I use the last 2 bytes to identify, because all others, the one that I want to identify do not have others, but E0, E0, all. So you can spell that out all, but in this case, I simply use, what is that? The last 2 bytes significant, which is a small endian, right? Small endian in the codified, not the big endian, but small endian. But anyway, so I use less to 2 bytes. I can, if that is the case, then I can print out. I can say power on, channel plus, channel minus, volume plus, volume minus, and mute. And then other than that, I can say press any button, press a button. Okay, that's what I did. So what we could do while you are modifying this, I'm going to open up the code that I made. This is the code that I made, right? And I'm going to compile it. And upload to the same circuits, Arduino circuits. And then I can open up a serial monitor again. Are you ready? Not yet?
To receive?
Yeah, to receive.
To receive, yes. Not to do the code now. We have to.
Oh, you didn't do that?
Yeah, no,
For example, if I press power button, power on, right? My monitor. If I press channel up, channel plus, channel plus, channel minus. Oh, is there something wrong?
Yeah, something.
Yeah, I think it's a codified wrong.
Gotta change the.
Yeah, it seems to be.
Oh yeah, I think I put it down. That is the reason. Channel minus, and then volume up, volume down, and then mute. Yeah, and all others, then it checks something else. Okay, that's what we did. Here, press power on, and channel up, channel down, mute. I want you to practice. I want you to complete the code. If you are ready, then I'm going to press. I'm going to control you.
Okay. Okay, we'll do.
I think this is it for today. I'm going to turn off this, and then we can still work on. Okay.
Professor. Oh.
I have to turn this off. My recording.